Welcome to Standing for Truth. My name is Donny Budinsky, and tonight we're exploring one of the most intriguing questions in all of biblical history. How did people live more than 900 years before the flood? And what changed afterward? To help us unpack this incredible topic, we're joined by a scientist whose work spans physics, cosmology, and biblical creation research, Dr. John Gideon Hartnett. Tonight, he presents a fascinating look at biblical longevity and how the scientific evidence beautifully aligns with the Genesis record. This is going to be a powerful, eye-opening program that strengthens our confidence in the truth of Scripture from the very beginning. Dr. Hartnett, welcome again to the Standing for Truth program. How you doing tonight, brother?
Good. Thanks for having me on, Donny. It's good to be back.
Well, it's my pleasure. I said, how are you doing tonight? But I guess it's tonight for me, morning for you. As Dr. Hartnett, you are in the future. It's also not your first time here on the program. You've been with us a couple times in the past. The first time you were here was for a comprehensive, leave no stone unturned program on biblical cosmology and overturning the Big Bang Theory. What an excellent program that is. I still go back to that. I still promote that and advertise it for people to enjoy and benefit from. And then the second program, going back several months at least, we had a seminar on the amazing science of young Earth creation where you focused on the decaying magnetic field, C14 and diamonds, and so many excellent topics showcasing exactly why it's a great time to be a biblical creationist. And so it's great to have you back. I do want to promote your material here. If I could, Dr. Hartnett, Doki Doki, appreciate it. My faithful mod in the chat, BibleScienceForum.com. Excellent material and content there. You can find articles, books, and more on not just one topic, but multiple topics. Young Earth creation, eschatology, and so many important topics for people to enjoy. And so, Dr. Hartnett, if I could, I want to give you a formal introduction for anybody who might be unfamiliar with who you are, and then we'll get into your talk, which I'm very excited for. John Gideon Hartnett is an Australian physicist, cosmologist, and Christian with a biblical creationist worldview. He has a PhD with distinction in physics from the University of Western Australia. During his research career, he worked at UWA and the University of Adelaide, hopefully I said that one right, and published more than 200 papers in scientific leading journals, in book chapters, and in conference proceedings. He was a founding director of an Australian startup, now commercializing his research on ultrastable cryogenic clocks. He has lectured around the world in churches and at conferences and written extensively on biblical creation, mostly in terms of astrophysics and cosmology. In other words, Dr. Hartnett, you're more than qualified to be speaking on these topics. And so, okay, unless there's anything else you wanted to add in terms of introduction, brother, we can get into your presentation.
Yep. Okay. Excuse me. Okay, I've got control here. So before we get into the detail of this, I always need to clarify that there are two forms of science, or two categories of science. Operational science, which is experimental, repeatable, and of course, always done in the present. I spent a lot of my career doing that in labs as a experimental physicist. And the second category is historical science. It's not repeatable. It tries to reconstruct some past unobserved events. It's closer to what we would call forensic science. And it relies on historical records and untestable assumptions. And a lot of what I speak on here today will fall into this category, into historical science. We just need to keep that in mind. In fact, all of the biblical history, or the record of the genealogies, the historical record, and all other ancient records are really an account of past history. And today we want to have a look, well, let's say the starting point of some of these records, historical records, are the ages of the patriarchs. And I've listed two here, which are the most, I would say, most commonly used by biblical scholars. On the left column, labeled MT, that's a Masoretic text that's in most Bible translations, most modern English Bible translations use that. And then on the right, under the label of LXX, which is the label for the Septuagint, and that record is also, I believe, worth looking at in this context. Now, it's worth noting that the Septuagint is heavily quoted in the New Testament by the apostles. Paul heavily quotes it, so it had a high standing with the apostles. And for those who are not familiar with it, it stands for, the label there stands for 70, LXX stands for 70, because it was a translation of the Old Testament Hebrew around about 200 BC. They translated it into Greek. And they say there were 70 scholars involved in that. So I'm going to use records from both the Masoretic and the Septuagint in this analysis. On the right, I have a plot of the age of the patriarchs taken from the Masoretic text. I've labeled a few. Noah, they're 930 years, was it 60? 960 years. Lamech down further labeled, and Enoch down further. I've labeled those last two because they're basically outliers, where the others, all the others prior to Noah, were ages somewhere between 900 and 970 years, in that range. And then you see at the moment where I've labeled it the flood, from that time, there seemed to be a very rapid decrease in age of the patriarchs. Now I've plotted here, I've plotted their ages taken from the Masoretic listings or record as at the date of their birth. That was the way I found it was best or easiest to be able to get a monotonic function that we could fit to. So you might think of this as, at that date in history, the potential for life was characterized by the age of that patriarch. So they are sort of like a, they symbolize the longevity of humans in that time period. That might be the best way to think about it. And then at on the date year 3000. Now on this plot, it's in years Anno Mundi, which is from the creation. So on the date of 3000, that coincides with the period of time of King David. And in the Psalms, he wrote that the average age, or the age you can look forward to, was 70 years. And so I put that in at 70 years, and then the time of Christ in 4000, also 70 years. I mean, and then again 6000 in the current epoch, also I put in 70 years. So that's essentially constant. These are therefore just some sort of an average over this time period. And we'll have a look at these a bit more as we go along. But for a comparison, I've plotted the Masoretic text against the Septuagint text ages. The blue dots are the Masoretic, and the red squares from the Septuagint. And now I've plotted it at time of birth still, but on a different scale of BC AD, where negative numbers are BC, before Christ, positive numbers are AD, after Christ. And you'll see then that the creation dates are not the same, obviously. The Septuagint has a creation date of 5560 BC, and the Masoretic has 4004 BC, which is Ussher's date of creation. So there is a difference in the overall timeline, or around about 1,500 years difference between the two data sets. And I've also, for the analysis that we'll have a look at from now on, I've removed Enoch and Lamech because they're outliers and don't really reflect upon the analysis that much, don't give us a whole lot of information. I've also, in this table on the left here, highlighted the year of the flood according to the respective data, from the respective texts. And you can see that they are quite different. Around about was a sort of about close to 1,000 years difference in the date of the flood. But we'll get into that also as we go on. Now, we want to talk about lifespans because quite obviously the biblical lifespans by either record, Masoretic or Septuagint, they live very long lives, above 900 years, up to Methuselah, which was 969 years. But they also both indicate a rapid decrease of their lifespans after the flood. So what could be contributing factors to cause this to happen? And this is probably the most difficult question to answer, but it's also very intriguing to look at the different factors I believe contribute to this, both biological and environmental. So I've got 4 points here which I think are worth going through. The first one is biological decay. Now, we all know that all systems eventually break down and decay. We age, we get old, and we die. This is second law of thermodynamics. Entropy increases, randomness increases. Well, that entropy also occurs in the genome of every living organism. This is called genomic information loss, and that's lost every generation. So it's lost in the just act of copying the DNA itself. There's a very good book on this written by Dr. John Sanford. It's called Genetic Entropy, and it's worth reading if you haven't read it. And he refers it to this time of rapid loss of longevity as a fact, as genetic entropy being a factor in that. But I want to point out another biological issue here, and we're calling it, well, it is called physiological resilience. And that is the property of an organism to recover, bounce back from a sickness or some sort of illness or damage to the organism, and how quickly it can bounce back. Point number 2, we will look at changes in the Earth's magnetic field, both polarization, energy, and stability of the field, in light of the Earth's magnetic field having an effect on aging. And I think this is an area where there's a more operational experimental research could be done. It's a very early in any type of research, but there are some clues that we can look at in that. And also we will have a look at past historical record of the Earth's magnetic field and how that might affect longevity. Number 3 is oxidative stress and other factors in the Earth's changing environment, which includes the magnetic fields, cosmic rays, climate, not just temperature, but actually the overall climate itself and how that may degrade the quality of life, and also geographic stability, which of course the flood itself created a massive geological event and changed the geography of the planet, and therefore you can imagine many different factors would have come in. Now, I'm not going to cover in detail all of this. What I'm looking at today may be a bit of a sketch, an overall sketch with some ideas that I believe point to where we could do further research and look to try and understand what happened around the time of the flood. Number 4, a very important point that many researchers don't recognize from a biblical creation standpoint. We have the sustaining power of the Creator and his sustaining power over his creation. And I'll explain again more how I see that being a major factor as we move forward. First, a little bit of experimental results in this is operational science, where early research on longevity, we've had a number of different lines of research, and this is one of them. From this paper, which was titled "A Moderate Static Magnetic Field Promotes this Roundworm's Longevity." So it's worth noting they talk about a static magnetic field, a moderate static magnetic field. So in the article, they state that aging is co-regulated by genetic and environmental factors. Life on Earth lives and evolves in a mild geomagnetic field. Now, I would substitute the word evolve there for maybe decays. I don't accept upward Darwinian increase of information when actually genetic entry tells us the exact opposite is occurring. So evolve in the sense of change does definitely occur, and it's a decay process. Yet, continuing with the quote, yet the biological effects of a moderate magnetic field on aging and the underlying genetic mechanisms remain barely unknown. Here we report that a moderate static magnetic field extends the lifespan of this particular roundworm, a well-established model organism in aging research. So this is worth looking at. Then how the magnetic field of the Earth may have had an impact on human longevity, in fact, on all organisms' longevity. Another paper now, this one is published 2022, talks about long-term exposure of a moderate static magnetic field on the lifespan and health span of mice. And they found by exposing these mice to a quasi-uniform static magnetic field, it would improve both their lifespan and health span of these naturally aged mice due to reduced oxidative stress. So, of course, the article then implies that they maybe could use that as a health remedy to reduce the aging-induced health risk in humans. Another article published in in Nature Communications, this was in 2021. This is written up and reported in Popular Mechanics, and I often read that for these type of reports. The headline said that humans could live to be 150, science says, but that's absolutely the limit. And this was some research done where they looked at the limiting factors on lifespan through this loss of the ability to bounce back after a setback, and they call that physiological resilience. So even without major health issues like cancer, your body will eventually run out of energy to help recover from even minor challenges. And this is, again, a second law, effect of the second law of thermodynamics, which we see a loss of energy and increase decay, which is a randomization event. Second law is always a one-way arrow of time effect. We're always running downhill, down the thermodynamic hill, and both of this ability to recover from a setback and the body's eventually runs out of energy, these are both second law type effects. Now, what they did in this research is they examined both changes in blood cell counts and the number of steps that groups took, treating these as two factors or as hallmarks of aging. They used databases of several thousands of people, middle age to older age, and they looked at their blood counts in the different age groups and their step counts per day in the different age groups. And the article in Popular Mechanics said that despite the two variables at a similar rate in the test subjects over time. And from this, they were able to plot. So initially looking at plot number C, the first one there on the left, they calculated what they called dynamic organism state indicator, or DOSI. And you notice the units of that on the vertical scale are in weeks, reciprocal weeks. That means inverse times. And so it's the inverse characteristic recovery time. And then by extrapolating these two different hallmarks of aging, if you like, the step counts and the blood counts, extrapolate them to the point of total loss, and it comes out at a range of about 110 to 170 years for the age or the longevity of the organism. So they said there is a complete loss of resilience and hence loss of stability of the organism state, which means death. So that's the limiting factor when looking at it from that perspective. They also looked at the inverse variance of this characteristic indicator, this DOSI, and they found that it decreased linearly in all the data sets, and they added a few extra data sets of about 5,000 participants who did surveys, so depending on their age, and they were able to survey these people. And they then also extrapolated this value until it vanished, that is where the variance diverged. And this occurs at an age in the range of 120 to 150 years, which again, this is saying death. This is the limit of longevity. So this is what they concluded from that research. The researchers are able to find the point at which the body would ultimately disintegrate as a result of the loss of resiliency. Every year, for example, think of the risk of cancer as a kind of coin toss with a certain likelihood of it happening. The longer you live, the more coins flips you must take. The point at which you take the last coin flip, they say, is somewhere between 120 and 150 years, a value that likely puts a hard limit on human life. So that means the limit of that's longevity, of course, assuming no accidental death or other effects that would cut life short. So this is like, again, this is a second law of thermodynamic effect of increasing entropy, where we see the body decaying away or disintegrating, and that resulting in a loss of this physiological resiliency. So they said that we conclude that the criticality resulting in the end of life is an intrinsic biological property of an organism that is independent of stress factors and signifies a fundamental absolute limit of human lifespan. And this was a quote from the authors in the paper. Now, I want to give you a bit of an analogy here. So I've prepared a small demonstration. Can you see this? Can you see that? It's a bell. And you can hear this bell ringing down. This is a niobium disc that has a very long ring down time. It's called ring down time. It's still ringing. Now we can go back to the slide. And so the ring down time is illustrated by this oscilloscope plot on the right. You see, even though I struck the bell and it still rings, the amplitude or the volume, the amplitude of that characteristic ringing sound slowly decays away. And if you have a bell that stores the energy for a long time, it takes a long time for the sound to decay away. And we then say that has a high quality factor or a high Q factor. And here I want to use this as an analog to a lifetime of living after decay has set in and its physiological resilience decreases. So this is an analog. I'm not saying we're bells or anything. I'm saying that the stored energy in the living organism is analogous to the stored energy in that bell. So this Q factor is like physiological resilience, the Q factor or quality factor. And it's defined in terms of the total losses in the system. So that means a low loss means high Q or high resilience. Simple equation, Q is equal to the reciprocal of the losses. In the case of human or any life, the losses represent the energy loss from the system integrated over a finite time period. This is a lifetime. This definition is in context of senile death, not due to accident or disease or being taken by God, like who was it? Was Enoch? Yeah, it was Enoch. It was walk with God, right? So we're not talking about that. We're talking about senile death, earthly death. And a high Q or high resilience means low losses. That means a low reciprocal age. So on the right here, I've plotted the reciprocal age of the patriarchs. It's the same data from the Masoretic text I showed you before, but now plotted as the inverse of the age of their age, inverse of their age, again on the Anno Mundi time scale starting from 0 at creation. And there's a broken line curve fitted to that, which is a exponential curve fit. And we see the fit is very good from the time of the flood, from the discontinuity. So I'm not trying to fit it to any of the time of the ages before the flood, before Noah, only after Noah, including Noah. And the fit is extremely good. It's this equation, number 2, shown there. Not that you have to memorize that or anything, but this shows the losses. We could say it's the organism's losses physiological resilience. And this is characterized by the ages of the patriarchs. And it has a characteristic loss constant. In this case, it's about 518 years. That characterizes how quickly those losses occur in the organism. We can also say that at time zero, that is at creation itself, the losses were negative. If you put a t equal to 0 in equation 2, you'll see that becomes a negative number. And so what does that mean? So the losses were negative, certainly 0, or really even negative at creation. And in physics, a negative loss means an amplification or a regeneration, which means no losses at all. So we could say pre-curse, there were no losses. Potentially pre-curse, Adam could live forever. But post-curse, there were some losses as indicated by their finite ages. Adam, if I remember, lived to 930 years. So he was affected by what occurs after the curse. So just continuing with this a little, and the timescales, I've got this on the right. It's the same plot. It doesn't look quite the same, but there's a reason for that, is because these are logarithmic scales on the vertical axis. It's the same as before, was a logarithmic scale, but I've extended that logarithmic scale down to 10 to the minus 6, which 1 billionth, very small number. And I've also plotted the time scale, time of birth, Anamundi, also on a logarithmic time scale. So, and there's one dot there for Adam. So that's Adam at that's the time of his birth, estimating it, of course, on the 4th day of creation. But I put in his age from the record. So that's really his age post-curse. And so we could say that if we add the pre-flood loss line, which is this solid horizontal line, and if we add that to the post-flood loss curve, that's the broken dashed line, we get a corrected piecewise equation. So that is before the time t0, that is where these two curves meet. The losses are a certain value, that number that's nearly 10 to the minus 3, 0.00107. That's before t0, and after t0, it's the exponential curve that we saw before. So it's a piecewise equation. And of course, something major happens at the time t0. It's like a singularity. We can solve these two equations, 3a and 3b, for t0, and we get 1640 Anamundi, which is very close to the biblical record. If you calculate from the that record, you get 1656. I think the error bars on that 1640 were something like plus or minus 10 years. So that gets you quite close to the Masoretic text, date of the flood. Now, it's worth pointing out something else. We don't know, we don't really know the history before the curse. I mean, we don't know exactly even how long it was, but, and I don't suppose to say that Adam and Eve were going to live forever. We don't know that. And because the second law of thermodynamics must have been operating from the time of creation. And under the second law, decay processes occur. Therefore, during the pre-curse period, whatever losses Adam suffered must have been regenerated, or those losses must have been cancelled out by the sustaining power of God. And then after the curse, God withdrew a little of his sustaining power up to the flood, right? So there was some constant level of this, of these losses that were maintained by the sustaining power of God. So that's why that's a solid, well, not solid, that's why it's a horizontal line, because the level of losses for the patriarchs was roughly the same. And it was because God was regenerating the losses in their body, the decay processes, due to, sorry, not due to, but using this sustaining force. To give you a little bit of a segue here, but to understand this sustaining force I'm talking about, think of Moses and the burning bush. He was looking at the bush and noticed that it didn't burn away. It continued to burn. Yet burning is an oxidation process where the second law tells us energy has been lost and entropy is increasing. So God must have used his sustaining power to maintain the bush burning without it burning away. So this is an example of God interfering in his creation to not to cancel the second law, but to regenerate the effects caused by it. And that's worth noting in this, that in our model, we have to include this sustaining power of God. It's a very powerful force and maintained constant losses after the curse, but prior to the flood. And then after the flood, the increase in losses were so enormous, so exponentially increased, that level of sustaining power would not have any effect. So if we also make a comparison between the data from the Masoretic text and the Septuagint, the blue dots here, the blue circles, are the Masoretic data that showed in the previous slide. And the red squares are from the Septuagint. And quite obviously, the exponential curve fits extremely well to the Masoretic text, whereas the fit is not so good. It has the same general form, but the fit is not as good to the Septuagint data. You'll notice also that the time constant from the Septuagint is much nearly double that of the Masoretic, which means those decay processes took longer to come into effect. Longer time means a longer decay, or a longer ring down time, if you like, using that type of language. So we could say the loss of resilience was fastest, or seemed to be fastest, in the Masoretic text data. Now, how you wish to interpret that, whether one set is more reliable than the other, we'll see. I have no opinion on it, actually, and I'll show you why later. But also we can say post-curse, the pre-flood average age was 935 years. That is the inverse of the losses before the flood. So that should be the characteristic age of the patriarchs before the flood, being sustained at that level by the sustaining power of God. And then when the flood, around the time of the flood, I should say, God released this sustaining power, or withdrew more of it, and there's a rapid exponential aging occurred. So he let it, released it in a sense, and taking away that sustaining power. So the losses rapidly increased up to the level of where we find it today, up above 10 to the minus 2 on the loss scale, using losses here to describe it. If you haven't seen this, Donny already spoke about this. We did a video several months back on the amazing science of young Earth creation. Well, the large segment of that was on the design features of the Earth's magnetic field, and also my model on the changing tilt of the Earth's obliquity, or the tilt of the axis against the ecliptic, and how that may have affected the core, the liquid core of the planet, which in turn had a significant effect on the Earth's magnetic field. Now, I will give some points in the following on that, but to get a full depth understanding of it, you should go back, and if you haven't seen it, and watch that video. It's quite in depth, a couple of hours long, if I remember. So if we look here at the changing obliquity, that is the tilt in the polar axis of the spinning planet, the Earth, as it moves in space. Of course, the Earth revolves around the sun, and it precesses. It's like a spinning top that precesses on its axis over a cycle that takes a complete full turn over 26,000 years. This is calculated by this formula called Newcomb's formula, and it's based on a calculation of the sum, or the total effects of the gravitational pull on the Earth's axis primarily from the moon, and to a lesser extent from the sun, and some smaller extent from the other planets in the solar system. And this is you could call this a secular formula that calculates the tilt of the axis over time. You see the tilt there on that figure is 23.44 degrees away from the north ecliptic pole, or you could say away from the ecliptic plane. And that is what secular astronomers expect to occur over history of planet Earth. However, the astronomer, South Australian government astronomer, actually, George Dodwell, up to his death in about the mid-60s, collected historical data on the obliquity of the ecliptic, which departed from the Newcomb formula. And this is somewhat controversial, but this is his data here shown in the red dots. I'll try and explain this plot here. The Newcomb formula is curve number 1. That's what they expect the change in tilt, obliquity there, of the Earth's axis to occur over time. And I've got about minus 10,000 years up to plus 4,000 years to see this slow, gradual change in tilt. Now, that is what they expect. The measured data are the red points, and the measured data agree with the Newcomb formula for the last few hundred years, where that has been actively measured. So that curve fit is a 5th order polynomial. I think nowadays they even go up to a 10th order polynomial using computational, high-speed computer algorithms. Dodwell, he published his data where he had collected it from historical records, going right back to that first datum at minus 2000, that's 2000 BC. And that is quite controversial because it departs very strongly from the expected Newcomb formula. I played around with different models to try to see if there was any type of fit, some sort of functional form that could describe that departure from the Newcomb formula. And I found a Lorentzian model that would fit it very well indeed. You can see there from the dash curve number 2, the dash curve is my Lorentzian model fit to all of the data, Dodwell's data plus all the modern secular data. And something we can say occurred at the time the model curve fit crossed the expected Newcomb formula, right? That was the expected slow gradual change. And there was some point where the curve has maximum slope, and that's some sort of singularity point. Now, later, I felt confident to label that as the year of the flood, of not the Great Flood, because that's the single most catastrophic geological, astronomical event that the planet Earth has underwent in its entire history. So it's a very significant period of time. Unfortunately, we don't have any other data points on the other side of that curve, but we'll just have to live with that. And I'm going to explore this a little more, give you a bit more detail, but there's a lot more detail of this in that other video presentation, if you go and watch that later on. Now, the Earth has a liquid core. The inner core is solid, and the outer core of that inner core, the outer surface, is liquid. This is a liquid alloy mix of iron and nickel, which means it's highly conductive and supports a very strong circulating current. The Earth is rotating, as we know, like a gyro, and the liquid inner core also, for the same reasons, is also rotating with the same rotation period as the Earth. And these are very powerful dynamos or gyros. Sorry, not dynamos, gyros. And a circulating core, liquid core, would also imply a circulating current that has been circulating from the moment of creation. Now, I looked at the effect, the interrelationship between the rotating planet Earth, and that's my slide on the right, with a rotating core, means it's rotating at the slipping. It could be slipping because it's a liquid at the mantle outer core boundary. But I've modeled it with the same rotation frequency because the Earth rotates once every 24 hours. And in my model, I've had the inner core rotating at the same. So, of course, there may be some slippage, there may be some resistance, but what's most significant is to look at the effects of the change in the tilt of the core as the Earth's axis slowly changes its tilt. So you see we've got a 23.44 degrees here for the current polar spin axis, and we've got the core spin axis at 14.28 degrees. So as the Earth's axis changes, how does the core axis change? That's what I investigated. And now we have two curves. The top one with the red dots is the same I showed you before, with the Dodwell data and the change in tilt with my Lorentzian model. And then the calculation using conservation of angular momentum, we now get this curve 3, I think it's green, and that shows how the core inclination changes. That's the inclination with respect to the spin axis of the planet, how that changes when angular momentum is conserved. So, of course, they both cross the secular curve. In the case of the core, the secular curve is curve 4. And they both cross the secular curve in the respective secular curves at the same moment in time. So there was the rate of change at that point was maximum when this singularity occurred. And I'm using this to give us the date of the flood of 3154 plus or minus 191 years BC. This is in very good agreement with the Septuagint, but it actually excludes the Masoretic text, and I'll show you more of that later. So you also note that the core spin axis changes much more than the Earth's polar axis. Of course, this is due to conservation of angular momentum. So from the Earth's core, we have a rotating core. From creation, from the moment of creation, we also therefore have circulating currents in the outer core, the liquid outer core. And that generates a magnetic field. And the simple magnetic field shown on the right is a dipole magnetic field that most people are familiar with. That's a ring magnet, but it's the same in a typical bar magnet, north and south. And so the Earth has a dipole field, but it also has other components of the magnetic field that we'll just generally categorize as non-dipole components. And the total energy of all those components sum together to give the total energy in the field. So the Earth's molten core is what generates this field. It's the circulating currents actually in the field. And if you have disturbances in those currents due to disturbances in the liquid core, then you will have anomalies in the Earth's magnetic field. Well, historical measurements have been made of the Earth's magnetic field. And the way this was done, these are historical measurements, meaning they made measurements in the present. They went out and found rocks and measured their magnetic dipole. That's why they're called archaeomagnetic intensity measurements. And they measured those, the dipole moment from the rocks. And there are many samples. And in this plot here, where you see with very large error bars, they use the calculated dipole moments from many samples and they averaged them together. And that's why even the time measurement error bars are very large, because there might be 10 or 20 samples at each point that is used on this plot. So we have for the, and this plot is now converted into dipole energy. Dipole moment is not quite the same as dipole, it goes as the square. So I've converted it into the dipole energy, and there's a reason for that. Over on the right, we see a blue, a red, and some green dots. They only cover about 100 years or a little over 100 years. This is the energy calculated by Dr. Russ Humphreys in the dipole and non-dipole field components from published measured magnetic field data. So this is data that was since the development of a magnetometer, since Gauss, the Earth's magnetic field energies have been measured. And I've plotted them on there, and I converted the archaeomagnetic intensity measurements into dipole energy, so we can compare them with the same points of Humphreys. These are the red points because it's a dipole field measurement for Humphreys. And I've also put the flood date on this plot with the error bars in that shaded region. So 3154 plus or minus 191 years. You'll see that where that occurs. You will note, and we'll look at this a bit in the next slides, but you will note that the energy of the magnetic field prior to the flood, and you'll see this within the error bars, is almost constant. You'll note that if you draw a constant line through there, it would pass through all of the error bars. And after the flood, you'll notice the magnetic field energy starts to increase, becomes fairly constant, and then an exponential decrease. And that is confirmed by the Humphreys measurements that it aligns with an exponential decrease over the last 100 years, which actually, over a short time period, an exponential is linear. So we could even say the decrease in the magnetic field over the last 1,000 years has been pretty close to a linear decrease, energy decrease. And as the energy has decreased in recent times, you'll find the non-dipole, which is the green dots down the bottom near 2000, that has increased, and the blue dots gives you a total energy. It's not so easy to see here, but we'll see over here where I've extended all this, and it's a lot easier to understand what's going on. Sorry for being a very busy slide. I'll try to explain some of this to give a picture of what is going on. I've removed the error bars from the dashed curve for the archaeo intensity measurements that represents the dipole energy. That's the black dash curve. I've removed the error bars only to make the slide less busy. Otherwise, there's just too much on there. So curve, what's the, do I have a curve number on it? Number one. It's actually curve number one. The black dash curve is the previous, showed you on the previous slide. And I've added Humphreys data into it. Now it's all got the same color in that curve. Another point to be made here is that the past dating of the archaeo intensity measurements is I say controversial, because this is a historical dating problem. And old Earth long age dating telescopes out all past dates to very long time scales, and I think it's not can't be justified because there's no independent verification. And so my decision here, the data within that pink rectangle, I've scaled the time scale smaller, compressed it by 20%. And I've done this to align it with the Masoretic time scale, the 5,600 years BC for the creation. However, I would say that these dates for this vertical axial dipole moment data, that's what we're looking at right now, is only qualitative. We can't say that it's quantitative because of the uncertainty in the time scale, the dates in which these measurements represent. However, we can still, I can say the same thing. It's the same curve as before, that prior to the flood, the energy in the dipole field, the magnetic dipole field, was approximately constant. And therefore, we can make an estimate of the energy in the non-dipole field, which is the blue curve. It's number 2 that you'll find aligns with Humphrey's data over there towards 2000. And you'll see that that also is roughly constant, because the error bars are actually quite large. They're just not shown on there. And therefore, we can say something about the Earth's magnetic field prior to the flood. But you also notice the light green dots. That's curve number 3. That's the total energy in the magnetic B field. That's dipole and non-dipole terms. Is slightly decaying, but fairly constant. This is a linear scale. And the total energy in the Earth, therefore, energy conservation, first law, thermodynamics, must be constant. That's curve 5. Therefore, the Earth was only heating slowly. That's the red dots down the bottom. That's curve number 4. So over time, the planet was heating slowly from the decay of the currents in the core. And then when you get up to around about 500 AD, then you start to see a much more rapid yet linear increase in the heating effect in the core due to decay in the energy in the magnetic field. So the light green up there on the right, curve number 3, you see is decaying very rapidly. Now, you could fit an exponential to that, but it's unnecessary because a linear curve fit, that's a linear fit, and it fits very well. So a bit of a summary here. The total energy in the B field, the magnetic field that is, up until about 1000 AD was nearly constant, and then starts to decay more strongly after that. So we have a quasi-static magnetic field prior to the flood that favors long life, long ages. So up to the flood, the dipole field was roughly static. That's the black dashed curve, number 1, and weaker after about 1000 BC. So it starting to become much weaker. And therefore, we see a decrease in the non-dipole field after the flood. And that starts to pick up quite strongly from about 1000 years after the flood, become very strong, down to almost 0 for the non-dipole field by the time that you get to the time of Christ, around zero on the time scale there. So those are the features I want us to look at in terms of longevity of human age. I've also drawn on here the core spin axis. It's on a different scale on the right to see where that has its maximum slope around the time of the flood, of course, and to see if there's any correlation with the magnetic field. Well, we see some features of the magnetic field, but it's not very strongly correlated. But we do see some differences. We see a near constant field before the flood when the core spin axis was starting to change and then come up, and you see a similar effect after the flood, but then as it decreases, if the inclination decreases, then we see quite in late in history, we see a very strong decrease in the magnetic field. Now, the core inclination is only a proxy. It tells us that something was changing rapidly in the core. So my suggestion is that the currents were heavily disturbed around the time of the flood, when the slope of that curve was maximum, and those currents were disturbed, and that then triggered something in the Earth's core with a long time constant, like 1,000 years or something, but causing disturbances in the magnetic field for then the dipole field to start increasing and the non-dipole field starting to decrease rapidly after the flood. I think that captures the point I was trying to make here from this slide. So if we can now go back to our data, both the Septuagint and the Masoretic, and I've plotted again on the BC AD timescale, not Anno Mundi, but the dates that were expected from the two different data sets. For the Septuagint, I've put a red line there, and for the Masoretic, a green line for the dates of the flood. The hashed region is the date of the flood with the error bars taken from the change in tilt of the Earth's axis. And you'll see that the Septuagint fits within that error bars, whereas the Masoretic is strongly excluded from that. And so that's now evidence favoring the Septuagint data and against the Masoretic data, even though the a previous slide, we showed a strong correlation with an exponential fit to the exponential fall off in ages from the Masoretic data. So here's something now which it doesn't strongly tell us which way, because different analyses show favors one data set over another. Okay, so now looking here, and I'm using the Septuagint age data, which is the blue squares, and plotting them against the obliquity of the ecliptic. This is for the planet Earth. And again, this is just to reiterate the tilt of the Earth's axis, the obliquity, the scale is on the right. That then is acting as a proxy for the change in the core inclination, which is acting as a proxy for disturbance in the liquid core, and therefore effects on the Earth's magnetic field. So these are just looking for correlations between the data here. If we just look at this pink rectangle, you see quite obviously where the cross is in the middle. This is called an anti-correlation. As one curve moves down, the other curve is moving up, and they're both on linear scales. And so we see a rough anti-correlation between the two. And so therefore, wherever we have a correlation or an anti-correlation, if you take the product of the two, the curve should be essentially a constant. Well, we can also see an anti-correlation in the data before 4000 BC. When the ages of the patriarchs slightly increased, we see a decrease in the tilt of the axis, right? So there's that you could also say is anti-correlated. And I've added, you'll notice over on the right in the year 2000, I've added the average age of 80 years, not 70. And even if you were to go up to 120 or 150 years based on the potential longevity of humans, it would make very little overall effect. It would have very little difference in this curve. And we'll see that in the next slide. So in this case, I've now plotted the ages of the patriarchs, the Septuagint ages, against the obliquity of the ecliptic. And the product, you could essentially say it's like looking at the product, but it's plotting one against the other. And in regions of correlation or anti-correlation, we should see a horizontal line. And you see that at the top. I've drawn the arrow of time in black arrows. And you see at the top, it's roughly constant, which shows a correlation or anti-correlation. And then in the middle, even though not quite constant, but fairly constant, as the arrow of time moves on, this curve, the S-shaped curve, moves downwards. And then down the bottom, as ages stabilized, the arrow of time is still moving down overall. You still see a general downward trend. And this indicates to me that, well, it's actually an obvious fact that the arrow of time is irreversible. So the effect on ages as the Earth's axis changes indicates an irreversible effect on the longevity of humans. Now, again, just repeating, I'm using the obliquity of the ecliptic as a proxy for the core inclination, which is a proxy for the magnetic field, which has some type of effect on the ages of humans. Now, the last datum is 80 years, on average, that is. So outside of some medical improvements in lifespans, they're not going to get much greater. So you see that broken arrow, I just pointed that towards 120 years. And it looks like that even with all modern medical developments, even if you could get to some current upper lifespan or intrinsic lifespan of humans today, the arrow of time is still essentially heading down in an irreversible way. So we are winding down, decaying away, and we will not be going back to the ages of the patriarchs. So these are my concluding remarks on this. The very long lifespans pre-flood was a feature of the created world, but since the times of the pre-flood patriarchs, the underlying physical properties, that is physiological resilience, for such long ages have been eviscerated. They're gone. It's irreversible. Running out of energy and loss of physiological resilience are effects of the second law of thermodynamics. And this is running downhill, down a thermodynamic hill. The arrow of time is defined by the second law. We know that. Intrinsically, we know that in all processes where entropy increases, it defines the forward arrow of time. Entropy always increases in all systems on timescales of anything above a minute, a few seconds, to days, months, years, and centuries. That indicates that forward arrow of time. There's no going back to the pre-flood state. Well, I should say, qualify that, not naturalistically. Only with the coming of the Lord Jesus Christ and his renovation of the human body, that is the new bodies in the new heaven and new earth, can long time spans, eternal time spans even, be achieved. Now, God has promised to give us a new body, so that changes the physiological resilience issue, and it could also imply second law is reversed, or it could be the sustaining power of God completely cancels the losses due to the second law, like in the case of Adam in the pre-curse state, where he could have lived, this is hypothetical, of course, could have lived forever. So this is the only way we can go back to like these long lifespans. In fact, they will be eternal lifespans at that point. That's it for the presentation.
Dr. Hartnett, as always, I am mind blown by just how thorough and technical your presentation is, with all of your arguments being backed up by the data, the numbers, the graphing, the secular literature. There's a couple papers there I really want to hone in on and touch on some more. A lot of good feedback, and you've sparked a lot of good discussion. We've got an energetic chat as usual. Dr. Hartnett, good mix of critics and non-critics. I have made a lot of notes based on your presentation, and I'd like to go through a few of the points and then also address some of these comments. And so one point that you made that I found really interesting, and if we need to, we can move back in your presentation and look over some of the slides, but you had presented a couple interesting pieces of evidence. I think it was in mice and worms.
Yeah.
That resilience collapses or improves, basically. And actually, perhaps we can pull up those couple of papers again. I put that in the chat for them to see. And can you perhaps reiterate the significance of that research, Dr. Hartnett, in terms of what you're arguing here on lifespans being longer in the pre-flood world and shorter now?
If you go to slide 6.
J6. There we go.
Slide 6.
That's
Yeah.
round,
Okay.
So that's the roundworm.
Okay, the roundworm. Yeah. So look, they concluded that there's a moderate static magnetic field has an has a tendency to extend lifespan, and so I'm suggesting these lines of research, because this is experimental research, is a clue to something about the pre-flood world. Of course, now that moves into historical science, you understand. But this is a clue that living organisms ideally are designed, created, not evolved, but created to live in a mild static magnetic field. And if we go to the next slide, number 7, this was the case of mice. They found something very similar. The quasi-static uniform static magnetic field improved both the lifespan and health span of these mice. And then they suggested, I didn't emphasize this point earlier, but that it could be used as an adjuvant for physical therapy to reduce aging-induced health risks to benefit animals and humans. So using this type of a magnetic field as a healing modality, no doubt, to extend life. Again, this is another clue as to what may have been the effect in the pre-flood world. Now, there's other factors. Right. I made a list at the beginning, and I didn't explore all of them. But there are other factors that occur in the pre-flood to post-flood world that are worth exploring also. So I don't think it's a one-size-fits-all, but I do think this magnetic field issue is an important one. And,
it's really interesting. And so how I understand this is that we have modern experiments showing animals live long, and like you said, it's multi-dimensional, it's not just one factor that's increasing lifespan. It's numerous due to environment, magnetic field decay, genetic decay, loss of resilience. But anyways, on this particular topic, I find it interesting because these Worms being exposed to moderate magnetic fields live longer. Mice exposed long-term to stable fields also live longer. So, okay, we can extrapolate that reasonably and logically, I believe, that before the flood, Earth's magnetic conditions may have been far more favorable to longer lifespans. And then after the flood, these conditions deteriorated. Makes sense.
So I would argue that in the pre-flood world, that's what my slide was trying to indicate, that we had roughly static magnetic fields for the entire pre-flood period. And this actually is, amongst creationists for a very long time, they've argued that the Earth's magnetic field has undergone an exponential decay. And that exponential decay has been over the whole lifetime of the history of the planet. I do not believe that is correct. That was that data came about. I'll move forward here. That data came about from Russ Humphrey's measurements that are very. Here we go. Back to this slide. These coloured data on the right are the measured data that Dr. Humphreys used to make that extrapolation that the Earth's magnetic field has been decaying since creation. I'm saying, number one, you can fit a linear fit to his data. It's just those tiny little red dots there. You could fit an exponential to it if you like, because an exponential curve, when you express it over a short time period, so in other words, it's a very small fraction of the whole domain, then it will fit a linear curve. It's only over the whole domain. If you have data over the whole domain, you can't fit a linear to a exponential. But in his case, it's linear. And the virtual axial dipole moment data, which is this archaeomagnetic intensity data, that fits the linear decay at least the last 1,000 years. It will fit an exponential too, but it's not necessary, because as you go back further, it departs from that very strongly. And so we can reject the exponential decay issue and say that in the past, particularly pre-flood, on this slide, you will see that this is the dipole energy. As I said before, you can draw a constant line through everything pre-flood, and you could say, because of the error bars being so large, and you could say whether or not you agree with the dates of those points, the actual field intensity over that period of time was essentially constant. And that's what encouraged long ages. But post-flood, the dipole energy in the dipole field, which I'm making the argument even that the dipole energy may be the most important component of the magnetic field. That's the one that we all think about today, with the north and south pole coming out up near the north and south regions of the planet. That's the dipole field. That's the one that's shown in this data, and that's what is important for life, a uniform static magnetic field. So that's my argument. Of course, this is a historical argument. I don't have I can never make a measurement of the effect of the past Earth magnetic field on organisms, because it's past history. You can't do an experiment on the past. So the only experiments we have are in the present.
Which is why you started the presentation with the difference between operational and historical science, the significance of that.
That's right.
And fascinating data. And so, as I understand it, Dr. Hartnett, you're using historical data on several things: Earth's tilt, magnetic field changes, and even core rotation, to basically argue that a massive event must have occurred roughly a few thousand years ago, according to the Bible, that aligns with the flood timeline that we see in the scripture.
Yeah. And surprisingly, it was surprising to me, it aligns best with the Septuagint, because amongst creationists, there's even a big debate about the timelines, whether it should be Septuagint or Masoretic or even this Sumerian text or some other, because there's other texts that have other timelines and so on. But it doesn't really matter from a young Earth creationist point of view, because we're talking about less than 10,000 years for the age of the planet. That's still young Earth. That's still very young compared to 4 billion years of a old Earth model. Yeah.
Right. Whether the Earth is 6,200 years or a little bit over 7,000, it's still, they're both under 10,000 and way too short.
And you'll notice I point out that the model data fits certain things better with one set than the other set. Which people like to be, I don't know what the word is. People like to hold on to something and say, well, this is it, But in the scientific world, we need to be a bit more flexible and realize that there are errors and there's limitations on the data, and particularly historical data. And therefore, we need to be a bit more flexible. So that's why I would not be dogmatic about choosing the Masoretic text over the Septuagint, but as far as the date of the flood goes, that's quite powerful. It aligns well with the Septuagint, but that's my model. That's my particular model, which is a model fitting historical data.
Well, multiple working hypotheses. I'm a firm believer in that. And I think that's what we're looking at here. And to your points, using the biological world as support, mice, worms, I find it interesting, and I'm curious if you're familiar with this. This has been a point of my study over the years on biblical longevity, where we actually have a certain enzyme or antioxidant, Dr. Hartnett, called superoxide dismutase. And it turns out that lobsters have an expanded repertoire of genes for this specific antioxidant enzyme.
Right.
And that actually helps with oxidative stress. And if you look into it, lobsters are said to, because of that, and also apparently they have better telomerase production, from my understanding, they could live a lot longer, easily over 100 years. So what happens in the pre-flood world, where you have humans that have more superoxide dismutase, more telomerase, more resilience. I mean, all of these things that we see in real time, we get an example like with the lobsters or with the experiments with worms and mice. And I think reasonably we can extrapolate that to make conclusions about the ages in the pre-flood world.
And the issue of genetic entropy, which you're bringing up with the lobsters, that connects to the physiological resilience issue and the loss of energy in the organism because of genetic decay. So genetic decay is a reference to the information in the genome being lost, but also there is energy. There's non-genetic entropy processes going on as well, where the cell structures are decaying. You have epigenetics involved. I don't know the details of all of this, but it's way more complex. And so we can wrap it all together by saying that physiological resilience characterizes a lot of this biological stress, or the inability, the oxidative stress, the inability to recover from some type of event, some type of stress event. So you can see there's an interconnectedness between these different lines of research and loss of longevity in the organism.
Well, I love this model, this viewpoint that you take all these different factors and they're interconnected. So it's a sophisticated model with a lot of details. And then we can wrap it all up in a neat little package, as one might say. And and make these reasonable conclusions based on these extrapolations to the pre-flood world. But I'm curious as to your thoughts, because I feel like any reasonably thinking person looking to these real-time examples, let's say in the biological world, or having any kind of understanding of how deleterious mutations accumulate, we're increasing in terms of our genetic load. But when it comes to telomeres and telomerase, if in the pre-flood world, Dr. Hartnett, if we have slower telomere shortening, we have longer initial telomere length, and then more active telomerase in somatic cells, which it seems like we have some real-time examples, like in the case of lobsters, combined with the superoxide dismutase. It makes sense, doesn't it? That in the pre-flood world, that would mean they're going to live longer, of course.
That's right. And then you could make the argument that those decay processes are now, I need to say this correctly. The effect of those decay processes is partially cancelled in the pre-flood world by the sustaining power of God. Now, the reason I say it that way is because it's also incorrect to say that the second law of thermodynamics was not operating in the pre-flood world or in the pre-curse world. It's incorrect. All the laws of physics were operating. They're part of God's creation. It's just God has another force, a sustaining power, where he is able to correct, or in the case of the pre-flood, post-curse, slightly improve, like make corrections or reversal to some of that genetic decay. And in the pre-curse world, the assumption or the inference is that it was completely corrected for, and that there's no limitation to the potential of life. So my points on the curve are really characterizing the potential life, because we only have the data of the patriarchs, but what about all the other people who were living? We would say that they characterize the potential for humans living at that period of time. You know what I mean?
Right.
And God is making the correction with his sustaining force. I mean, even some of those those godless people in the pre-flood world, they didn't realize how thankful they should be, because the Creator was sustaining their life by at least partially nullifying some of the second law effects.
Well, I love the way that you ended the presentation as well, because in many ways it's an appeal to the gospel, where the only way we're going to have that kind of resilience again, of course, is in the resurrection, if we're saved, if we're spiritually regenerated and receive a new body one day.
Yeah, that's right. Now, I'm not suggesting that there's anything natural that we could naturally become, live long ages again. I mean, I was very clear about that. It's got to be supernatural, in the same way that sustaining power of God is a supernatural power, and that God will.
Well, I was going to say, isn't it interesting though? And I completely agree with you that there's no way. There's clearly God has removed some of his sustaining power. It's never going to happen again. But I've done some research. We got some videos from speakers that aren't even Christians, but they're into the whole transhumanism movement and all this, which we're totally against. It's all demonic, satanic. But even they have pointed to a lot of these arguments. They'll look to CRISPR technology. They'll point to the what we're talking about with telomeres and telomerase and superoxide dismutase. And they argue that, if we tap in and maybe correct some of these DNA mutations that are related to better DNA repair enzymes or longevity genes, that maybe we could start to live again, to 1,000 years old, or cure aging, cure death. Now, we know as Christians that no, our hope is not in this world. Our hope is with Christ. But isn't it interesting that even people outside of the Christian mindset are recognizing some of these factors, Dr. Hartnett?
Yeah. Yes, it is. In fact, the study that's published in Nature Communications captures just what you're talking about. I mean, it captures it at a higher level, just looking at blood counts and step counts for people as they're aging, that's like scooping up all the causes without looking at the detail why. But it puts upper limits on physical age, that
Right.
physiological resilience issue, so that the telomere lengths and all this sort of stuff is all captured in that experimental study, which sets upper limits. I mean, you can't get away from it. It's entropy is a bitch, as they say. You just can't beat it.
It's true. You can't beat it. Yeah. I mean, you just wake up every morning and you can see, and the older we get, we feel it. That's for sure. And on that, and on that entropy, genetic entropy, I'm just going to put this up because a lot of the critics, they don't really, in my opinion, have good responses to genomic decay or mutational meltdown, so on and so forth. So I wanted to respond to this with a paper, and then Dr. Hartnett, I wanted to get your thoughts as well. So the analog zone says bare assertion with the entropy part at the beginning, talking about how there's an increased genetic load and deleterious mutations are accumulating and selection is limited, so on and so forth. Anyways, we could refute their assertions or denial of this right from the conventional literature, Dr. Hartnett. I've got an entire PowerPoint on this. And notice this, because a lot of times you'll cite Genetic Entropy, which is one of my favorite books. I've got it behind me in my collection somewhere. Incredible book, demolishes evolution. But anytime you bring up that book or bring up the term genetic entropy, critics, militant critics will say, oh, well, Dr. John Sanford, he's a young earth creationist. You can't take him seriously, even though I like to point them to Dr. Sanford's talk at National Institute for Health within the last 5 years or so. We have it uploaded on this channel. National Institutes for Health is not a creationist organization. And he gave a talk there on genetic deterioration. But anyways, this paper here, Kitely and Lynch, not a young earth creationist paper. It's not contested. Notice what they say here, Dr. Hartnett. In summary, the vast majority of mutations are what? Deleterious. This is one of the most well-established principles of evolutionary genetics, supported by both molecular and quantitative genetic data. They admit that a lot of these very slightly deleterious mutations are actually effectively neutral. So what we would say as young earth creationists, interpreting these quotes, interpreting the secular literature on this issue, is that the majority of mutations are actually, they're not strictly neutral, where there's no harm at all. They're slightly deleterious, but they're not large enough for selection to actually see. And so what happens is they spread over time, they degenerate, they put shelf lives on genomes. And perhaps you can reiterate your point here, Dr. Hartnett, because how I view that then is, okay, if today we have an increased genetic load, we've had thousands of years of low impact, slightly deleterious mutations accumulating over time. Well, if you take this back thousands of years ago into the pre-flood world, well, then by definition, that means we'd have less mutations accumulated. The genetic load wouldn't be as high or extensive as it is today, and therefore fewer mutations, healthier genomes, healthier human beings, longer lifespans.
That's right. You've said it all. I mean, I agree. I mean, that's the key point that you make, that those mutations are slightly deleterious and they can't be selected for. And that's the problem. They accumulate in every organism until it reaches a critical amount. But this is just one feature that is very, very hard to get around. You can't get around it, in fact. And in the pre-flood world, those slightly deleterious mutations were also accumulating. That we're not saying that there was any difference. There may be slightly different environmental factors, but the sustaining power of God was set such that quality of life, that Q factor number that I was showing you, which is the inverse of it, is this physiological resilience. That value was controlled, fairly tightly controlled, to the value of about 10 to the minus 3, when it could have been, and that was the point of one of my slides, it could have been any number you like, any figure. Let me see, slide number. Is it this? Yeah, slide. Yeah. No, number 16. 16. Go back a bit.
There we
yeah,
go. God
here.
sustains.
So on a log scale plot, yeah, I go to the next one. Yes, 17. Yeah, no. Yeah, that one. So on a log scale plot, you see the reciprocal age, which is this. It's the inverse of the quality factor, which is this physiological resilience as determined by inverse years. That number could be as small as you like in theory, but it's not. It's a number that, I know this is a log scale, and a lot of people can't really comprehend what a log scale means, but it means it's a sizable constant value in the pre-flood world. So all decay processes were still occurring, but they're being corrected for. Now, if you have an exponential accumulation of deleterious genes in that time period, you also have an exponential correction factor that's cancelling it out. It must be the case, because that defines the quality factor for life, which is, we would call in another way, we would call that longevity. And that number, that line, represents 935 years. So that's the number that averages through the ages of those patriarchs during that time period. So what I'm saying is that the sustaining power of God is very powerful, very powerfully correcting for the effects of what we would call well-established laws of physics. The critics might say, well, where do you get that from? Well, we get it from God, of course, but, in the secular world, it's not uncommon for cosmologists and other theorists to talk about syntropy, reversing of entropy under conditions that they need, because entropy works in their Big Bang universe against them. And so oftentimes you'll hear where they theorize, or they might have a universe before our universe, an anti-universe, where time flows backwards and entropy doesn't increase, it decreases. They postulate all these sort of things. So I think I have a better foundation to postulate this sustaining power of God based on the biblical record than trying to prop up some secular theory, if you know what I'm saying. So
Right.
it's not without precedent. It's not without precedent, such a force.
So once this physiological resilience collapsed after the flood, God removes some of his sustaining power. Now we see that humanity could never regain that 900-year lifespan naturally, Dr. Hartnett.
Exactly. Because you could say on this plot, this reciprocal age, you imagine that solid black line, the horizontal line. If you move that up to the line at the top there, where the three dots in the years 1000 BC to 2000 AD, if you move that solid line up to there, that would be like saying that in that time period now, the losses have reached a constant value, but more than an order of magnitude, it looks like around about 20 times larger losses than they were in the pre-flood world. Well, that's consistent with the reduction in age, right, from 900 down to 70 years. So that characterizes the increase in this well, no, let's put it the other way around. The decrease in the resilience, the biological resilience. So it means a shorter lifespan because that resilience has gone. Got to get these the right way round.
Well, isn't
the
it
resilience has gone? The time of recovery has gone up. I mean, the time of recovery has gone up. Eventually, it would get to a point where it doesn't matter how much time you have, you can't recover. That's the whole point, and that means
that's right.
The age has gone to zero. You're dead. So
Well, it's perfectly said, and I find it incredible that when you plot the ages of the patriarchs, they follow a smooth exponential decay curve. The exact pattern, from my understanding, that we would expect if the human body suddenly experienced a greater aging loss, basically.
Well, it is.
After
It's
a global catastrophe.
Yeah, it's some type of shock, system. There's another caveat there. I keep trying to give all my caveats to these things because of the ages of the patriarchs were so long. I had to play around looking for the way you could plot a monotonic function. In other words, it's systematically increasing or decreasing as a function of time. But their ages are so long that if you say plotted the midpoint for the date, midpoint of their age, because they're overlapping, you don't get a smooth monotonic function. But I found if you plot it as a function of their date of their birth and consider that the potential for life at that time, so at the date of their birth means the date they're born, whatever the number is, they have the potential to live that long. So if, say, Noah, for example, he lived to 960 years. So at the date of his birth, he had the potential to live to 960 years. So if you look at it like that, then you get that smooth exponential decreasing curve, except for Lamech and Enoch, that aligns extremely well with the flood, which I find is pretty remarkable, in fact.
So I'm curious, in light of what you're saying on the decaying magnetic field, environmental reasons, I think epigenetic reasons for the losses that we see in longevity after the flood, because of some of the effects of the flood, Dr. Hartnett, these catastrophic processes, whether or not you hold accelerated nuclear decay or not, worldwide volcanism, so on and so forth. I think we have heat sinks to put a lot of this heat in. But my point is, a lot of the radiation and heat and energy produced from the flood, I assume we'd have some effects in the post-flood world, perhaps in the rocks, and perhaps we have more radiation in certain rocks or chemical imbalances in certain caves. And so do you believe that would have possibly had a negative effect on some of these isolated people groups that evolutionists argue that genetically or in their morphology or phenotype we can't explain? That's their assertion, like Neanderthals or Erectus, Hobbit, Naledi, so on and so forth. Do you think that it's possible that they and other people groups could have been affected by the heat, energy, and radiation produced from the flood, Dr. Hartnett?
I agree. It becomes a very complex multivariate problem because that's why I mentioned geographic issues. It depends on location. It depends on where you are. It's multifaceted. It's actually a very complicated problem. Maybe we should employ some AI to try to analyze large databases to see if we can sort of narrow this down. But I agree with you that there may be exceptions, maybe outliers, appear to be outliers, and they could go either direction. Certain people group that live for very short ages because of lifetime exposures to radiation, for example. So yeah, so it's a complicated problem, and it would be nice to have. Well, look, you can't turn the clock backwards. This is the problem. This is the problem with historical science. So all we are doing is continuing to make collections of data for past events or past records, and try to see where we can put those data in. Now, look, I don't know much about population studies in a post-flood world. It would be interesting if we had some, to see if we could. I know some people have looked at this, to put modern ages on the timeline. In well post flood is what I'm talking about, but maybe even where there's still some significant change in that exponential curve, to see how those effects, and to see about geographical location. Could you imagine you could have a people group in one location and another people group in another location, and see if their ages follows the same trend line?
Yeah.
And
Yeah,
if it doesn't, what are the potential reasons for the difference? It needs a younger person like you, Donny, to spend their life digging through vast quantities of data. I'm just trying to present a big picture here today. That's all. I'm trying to do the easy
You've done
work.
an excellent job. It's such an interesting topic. And again, I like how you take real-time data, papers that we can read and look at with these experiments, like with the roundworm and the mice, and then apply them or extrapolate them reasonably, I think, into the past, into the pre-flood world. And I believe we can do the same thing with a lot of these local people groups from the past in the immediate post-flood world, like Neanderthals, for example.
Yeah.
That evolutionists will say, oh, well, the Neanderthals just had way too many mutations for us to explain in the biblical timeline. But it's interesting because I can pull up, I've done a lot of study on this. I've had AI help me run some of the numbers, but there's real-time papers that you can look at now, 2022, 2023, that show certain families exposed to environmental chemicals and radiation and so on and so forth, where they actually accumulate per generation 2 to 7 times the normal amount of mutations, because what's happening is a lot of their DNA repair enzymes are being destroyed due to these chemicals and radiation. And so wait a minute, in the immediate post-flood world, you could have, I believe, some of these groups that are living in harsher conditions, exposed to radiation rocks like Neanderthals, where rather than only accumulating, let's say the mutation rate today is 100 roughly per person per generation, that's what we understand, it could have been 4 times that amount for several generations.
Yeah. Well, also the issue of cosmic rays, I never got into that, but generally speaking, creationists have assumed a decaying magnetic field, and therefore in the past, the cosmic ray, the Earth was shielded more from cosmic rays because of much higher intensity of magnetic field. But the data I presented today seems to indicate more of a constant pre-flood magnetic field, and then about 1,000 years post-flood, then it's starting to decay quite strongly.
Interesting.
So the Earth was protected in the pre-flood world by a higher magnetic field than it is today, but we can't really say that it was due to an exponential fall off. But maybe we could say it was due to a design feature of a static magnetic field that protected the Earth up until roughly the period of the flood, and then goes on a bit past the flood, but then in a post-flood world starting to decay. And so you now have the effects of the sun, on radioactive decay processes due to impact of solar radiation. I'm talking about high energy particles, cosmic rays, which are from the cosmos. And and so those effects could affect decay processes. I'm reminded, I can't remember the exact matrix, but I'm reminded that there was a radioactive decay process that they found was modified by external radiation. So
Wow.
I can't remember which it was now. It's be worth looking up. But this was an experiment in the lab, of course. By changing the strength of external radiation, you could modify the decay constant. And because, of course, the argument has always been in the past that radioactive decay processes are not affected by anything external to them, nothing chemical in the chemical environment or in radiation environment, nothing like that can affect the decay process, and therefore it's a reliable clock. Actually,
Right.
there are many lines of evidence that show that that is just not true. And so it's, again, another possibility. Of course, this is like secondary effects of changes in the cosmic ray intensity. And that also could have some effect on somatic cells and other issues like that, particularly, say, after about 1000 AD, about 1,000 years after the flood, where these effects could be quite strong. And we are living with them now. No wonder we only lived to 70 years, or
Right.
80, I hope.
Yeah. If I look tired on some days, I say, hey, I have the most mutations that I've ever had today. You know, they're accumulating. There's nothing we can do to stop them.
A solar storm or something hits you.
Right. Well, you know, and thank God we got that hope of glorified bodies, no more pain, no more suffering. And so what an amazing research project. Everything you're saying is just, it's good brainstorming too, because I got all these ideas floating around that you want to get out there on paper and in research. But Dr. Hartnett, this is a big one. This one came up so many times in the live chat that if I had $1 for every time I heard this argument, I'd be a trillionaire. And so people are wondering, critics are wondering, why should we as young earth creationists take the ages of the patriarchs that we read in the scriptures as modern ages, so I guess literal ages, when you have ancient civilizations or cultures like the ancient Sumerian kings list, which have kings living to tens of thousands of years old? Just an exaggeration. So how come the scriptures are not just exaggerating?
Well, I suppose it's back to the starting point. I think I was making notes on this talk and I forgot to include this point, but in terms of historical evidence, historical science, we are all subject to certain sets of assumptions, and those assumptions are very, how would you say, they're foundational to everything we do. And so in my case, and yours, I think also, there is the foundation, or the starting assumption is that the Bible is correct. The biblical text is the foundation upon which we can build everything. And then remember, it's historical. So we have to have an historical record that we can trust. Now, I know I've looked at the Sumerian kings list and various others as well, some other records as well. And they don't have the same credibility in terms of who the author of them is. Now, when I say that, I use author in capital A because I believe in the authorship of the Word of God by God Himself. And look, maybe it's not always perfect because humans don't always get things right, but largely we have a very accurate historical record. And I've shown you today even the fact that there is some disagreement between two of those records. But depending on which way we take that information, one of them, the Masoretic or the Septuagint, fits better to different aspects of the model. Anyway, so I'm back to the assumption. And my starting assumption is that I can I can rely on the scripture, the biblical record. Now, to counter that, not counter it, but to the opposite side of those who argue this, they would say they have no assumptions. It's just blatantly not true. Everybody makes assumptions, and even the assumption of believing some document that it represents a true history is an assumption in itself. I'm just open and upfront. I've been criticized in the past by different people who say, "Oh, he's got a big problem. He uses the Bible as the foundation of everything else, of physics, of everything, of history, everything," as if that is a valid argument. Well, I'm upfront about it, and so this is how I would answer that. There's a lot of noise in a lot of those alternative data sets, and so which are you going to choose amongst all the noise? I choose the biblical account, and that makes much more sense to me.
Well, especially because the historical and scientific data is actually lining up quite nicely with what the Bible says. And I think it's pretty obvious that a lot of these pagan cultures, they have perverted or warped interpretations of what the Bible describes. So, for example, the Sumerians simply inflated the story.
Yes, that's
that
right.
Genesis has preserved, right? In terms of I mean, it's so obvious that those ages are exaggerated, tens of thousands of years old. And so it seems like that King's List is just preserving basically a corrupted memory of the real long pre-flood lifespans. And we see that in ancient Egypt. You can get an echo of Adam, Eve, and the creation story in ancient Egypt, Noah and the flood.
You can look at many different myths of ancient peoples. Like the flood stories. You find Australian Aboriginals have flood stories, but some of them escaped on a floating piece of a log. You know, right. I mean, there's certain aspects of the story that you can say you agree with, but then 90% of it is just rubbish. But I agree. There's many myths and ancient stories, and how do you decide which you're going to use? Comes back to the same thing. You know, what's the starting assumption?
That's right. And you can tell, okay, in light of everything you've been discussing here today, Dr. Hartnett, those factors, that understanding makes sense in light of the ages and numbers that the Bible gives. Those are relatively realistic numbers, but then these pagan cultures, they just blew them into myth, tens of thousands of years old. No data is fitting that, but the data is fitting 900 years old. And I'm curious as your thoughts. We find a lot of these legends and stories from these ancient cultures, including pagan civilizations, of the golden age where man was able to live to 1,000. Yeah. And so are these all echoes of the true story found in Genesis?
I think they are. I mean, you've got your what do you call it? The what's the name of the civilization? I don't slip my mind. Under the ocean, you know, the
Atlantis.
Right. I mean, you hear this being blown up every now and again, this golden idyllic age where everything was perfect and you know, but the reality is, in the post-curse world, there is no such thing. This is like the heart of man. He's desiring heaven. He doesn't even know that he's desiring heaven, and he writes in his literature, you know, projects onto some ancient artifacts or something what he would like it to be, would like to believe it to be. But yeah, I think there is a core. There's often a core in every myth that's true. There's a core in every ancient story that has truth in it. But it's also the evil heart of man that tries to take credit to himself, right? I mean, we could extrapolate this to modern man today and his desire to live forever. We haven't talked about this, but through machines, through the transhuman agenda to overcome the limitations on life. Well, that's all generated by the heart of man. I mean, he wants that in his life. He's never going to get it because the second law applies even to his machines. The machines fall apart. I'm not saying they could ever transfer human consciousness into a machine. That's an impossibility. But even if you were to give them that, then they would have to constantly repair their machine.
That's
and,
right. A good point.
And the resources of the planet, due to second law of thermodynamics, will eventually run out. They have to.
Mm-hmm.
So then they say, oh, we'll go to the planets. We'll go to the universe. Well, eventually the universe will run out of resources also. Second law never stops. Energy is being used up. First law, energy is decaying away under second law, and the useful energy, Gibbs-free energy, becomes less and less. And then the universe, as they seem to all agree, will peter out into a cold, lifeless existence.
It's a very sad story. The secular story. It is.
You know, but I've looked into a lot of this AGI stuff and AI. I mean, they're expecting a singularity. They're expecting life to arise from non-life in a large enough bank of GPU processors, and that life can just arise out of what's called emergence. It's actually that's a misapplication of a real physics principle of emergence, but because life is not found in the molecules themselves. Life is way more complex than that. It's even not really found in the biomolecules either. I mean, the coded information on the DNA is important for life, right? Because it's the design blueprints for life. But you know, life is something more than the chemistry, than the biology, than the atoms. Life is something beyond that, and I don't think any secular scientist could ever actually tell you what it is. So that's sort of going in the opposite direction. I think, back to my final point, it's only through salvation in Jesus Christ can we truly have eternal life, can we live forever, because our life is sustained by the Holy Spirit of God. That is the spark of life that God breathed into Adam, who was made of the earth, of the dirt, the molecules of the dirt. God rearranged all those into that complex form, but then he breathed life into him. That's what the Spirit means, right? It means, Spirit means breath. The breath of life is God breathed into Adam. And that's what life is. I mean, so humans, atheistic humans particularly, want to bypass the Creator and to solve the problem of limited longevity, overcome the 70, 80, 90 years or something. My mother's 94, so she's beaten 90. And but they want to live forever.
That's right.
And it's not possible without the Creator, without Jesus Christ. It's impossible.
Well, you said it perfectly. Only resurrection and the renewal of the human body in Christ restores immortality.
Amen. That's right.
So, Dr. Hartnett, as we start to wind down here, I have just a couple kind of off-topic questions that I wanted to save for the end.
Yeah.
In order that we can leave no stone unturned on the
Yep.
topic at hand. Many people have seen your previous programs, Big Bang Cosmology, and then the last one on incredible evidence for young Earth creation. What a great show that. I mean, they're both so informative. And so this questioner, for example, he's asking JJT Creation Science. Thank you for the question. Appreciate all the participation and engagement. We've had a high energy level chat, some stimulating discussion going on. It's such a fascinating topic, though. that it's, I've really enjoyed this, Dr. Hartnett. So he's wondering, after all these years of astronomical discoveries, what is now your current stance on the cosmic axes of evil?
Okay. Look, I haven't seen any evidence that would, let's say, destabilize the existence of the axis of evil. The cosmic microwave background radiation issues are still there. There's a number of different lines of evidence. The polarization of galaxies, the spin directions of galaxies, north and south, the asymmetry in the mass of the universe above and below the galactic celestial equator. These all seem to be still there, still problems. So look, I don't see any change. There was one problem that's not directly connected to the axis of evil, but well, it is connected. It's to do to the cosmic microwave background radiation not casting shadows in the foreground of galaxy clusters. That I pushed one time as strong evidence against Big Bang. Now, that's not directly caused the axis of evil, but it is connected to the radiation background issue, and that we've had to drop. I wrote about that 10 years back, probably now, or maybe less. But otherwise, these other issues are still all there. These asymmetries, our galaxy in a cosmic void is still there. That is another one. There are many along this line, some of these issues like this, and they remain a problem. That is the underdensity in a certain region, overdensity in other regions. That's what the cosmic void is, that we seem to be living in an underdense region of the universe and that we're at the center of it. Now, that's way more wide-ranging than that one question, but I still think that's a problem.
Well, this one here is related to what you just said on being the center of the cosmos, I guess. He's got a follow-up, says, or asks, do you still think that the Sloan Digital Sky Survey supports our galaxy being at the center of the cosmos?
Okay, this is a little bit more nuanced, this one. From a biblical standpoint, I see no problem with our galaxy at the center of the physical universe. Okay, from a spiritual perspective, we definitely are at the center of the universe. But when I investigated this large galaxy survey and looked at let's say the piling up of galaxies located at how would you say, certain distances that we could say preferred distances. So they were so what we have is when we look at the galaxy survey, we are converting a redshift space into a physical space, and that's part of the problem. That in redshift space, it looks like the redshifts are at certain characteristic distances, and so that from that it looks like we're at the center of a large spherical structure with the Earth toward the center, near the center, and that the galaxies are at discrete distances moving away from that, sort of like shells or rings moving out. But that's in redshift space. The problem is you really have to do it in physical space, real space, and this is part of the problem of cosmic variance, of the uncertainty in cosmology. Some years back, I went to Institute of Creation Research and and convinced them, because they had a cluster of computers, I suppose they were a cluster of servers that were acted like a small supercomputer, mini supercomputer, if you can, I can use those words. And so they did analyses. It was Jason Lyle was there at the time with Jake Hebert, and they did an analysis trying to model the galaxy density. This is now in physical space, real space, and to see if we could draw such a conclusion. They did make a lot of progress, but they ran out of time and support, and they never concluded it. So the best they could say to me was the result is inconclusive. Look, I like the idea, but I have to tell you it's inconclusive to say that it supports that. It certainly, if it were so, if we were at the center of a large physical structure with concentric rings of galaxies at discrete distances, then that would be great, and the survey could support that. But I can't say that it requires that. I can't say that, and that's part of the problem with cosmology. It's historical science. It's not operational science at all, and a lot depends on our assumptions, our starting assumptions.
Dr. Hartnett, your views, as well as we've expressed in past shows, but we have new viewers, new subscribers, and many I know have read. I've got your book, Dismantling the Big Bang, read that years ago when I was a new Christian. Your views have altered a little bit on the best solutions to the distant starlight issue.
Yes. I think, yes, we were going to talk about that at some stage, but I did do an interview with Rebecca, and there's a very good video there on YouTube where I covered a lot of that. It was earlier this year, but I've come to my own personal conclusion, surveying many of the different potential creationist solutions to a starlight travel time problem in the universe. I've come down to believe, like Jason Lyle, Dr. Jason Lyle, that it's actually quite simple. It's you know, I could haul out a book and call it the conventionality thesis, if you like, and spin your head with a lot of terms. And this problem has existed. The conventionality thesis problem has existed for more than 100 years. And it's the fact of the matter is you can't measure the distance between clocks separated by distance. If there was a way that you could calibrate them, then you could make their measurement, but you can't. And this is the whole problem. The clocks are always uncalibrated. But that's the physics side of it. The textual side, the biblical evidence side, is the natural language that we use is in the Bible. When God talked about creating the stars, creating the starry heavens, he used natural language that there is no travel time problem. So the definition of the time of creation is when you see the light. And this is part of the conventionality thesis that you could argue, oh, that's just a convention and it's not the real moment of creation because you have to calculate the speed of light back billions of years. But no, that's not right. You could say that by definition, and you can't refute this, that the moment of creation is at the moment of observation. There's no way to refute that in the universe. And there's many very nice verses in Isaiah that, talked about God creating the stars. And he says, and the connotation was instantaneous. They stand up together. And so I think this is a very important line of evidence. I have a I created a PowerPoint slide a presentation. You can go to my website. It's called "Can We See into the Past?" You just search that in the search box, and I tried to make that as simple as possible for people to understand it. And I presented it to a small group of people who are already confirmed biblical creationists and asked for their feedback. It was about 20 people. Those who are more scientifically minded couldn't understand it. But those who were not scientifically minded, who are thinking more just like they might read the Bible when God said and he did, they said, that's the clearest thing I've ever heard, that God simply said and he created it. And therefore the time scale is as God said. And you don't have to worry about figuring out the one-way speed of light and all these sort of complicating factors. You just take it as gospel, what God said. So to boil this down, if I look out into the cosmos now and see the stars or see some explosion or some feature, I can simply say it happened at that moment when I saw it. So if we go back to creation, day 4, God created the stars, and say hypothetically you had a time machine and you went back and you were standing there. Of course, that's not possible, but the moment the light reaches the earth, and if you were standing there, you just saw it all happen in the moment. That's the moment of creation. So it's very simple and very simply defined that way. Go ahead.
Yeah. So basically, in its most basic sense, we're seeing light even in the furthest reaches of the universe, the most distant galaxies. We're essentially seeing it in real time. Those events that take place, they're reaching our eyes instantaneously.
Absolutely. It's all real time. And even the not Hubble, yeah, shows how old I am, Hubble Space Telescope, the James Webb. The James Webb, now it's more than 50% of these distant red blobs in the observations of the James Webb. I think it's up to over 300 of them now. More than 50% of them, when they do a calculation based on their assumed redshift distance, they're too large. They don't fit the Big Bang model. They're too large. They're too luminous. But if you just say they're just like any other galaxy, mixture of galaxies that we see all around us in the not so distant universe, then they're representative. The evolutionists say 50% of them are too evolved. Well, we wouldn't say that. They just are what they are, And I think we talked about this issue in that previous discussion.
This one right here. Since that talk we gave, or that you gave, the discussion we had, a cosmologist dismantles the Big Bang Theory, which you did. We've had no good serious rebuttal or critique since then. In that time period, because you have a lot of evolutionists, and I've seen the old Earth creationists, for example, at Reasons to Believe, Dr. Hugh Ross, they had a panel discussion on the James Webb Space Telescope. And I've heard many critics say that we're basically overstating things as young Earth creationists. We're not fully representing the James Webb Space Telescope data, because we've pointed out that, well, your galaxies in the most distant parts of the universe, as you said, evolutionists are saying, oh, they're too evolved. And we would say, well, no, because they're created, they're mature that way. So are we really overstating things? Have what a lot of us young Earth creationists, let's say Dr. Jason Lally, yourself, have said? Because from my understanding, these are in many ways confirmed predictions based on things Dr. Jason Lally has said. All of this data, does it still stand and support young Earth creation, or are the critics right?
It's what we would expect in a diverse universe. It's exactly what we would expect. And based on conventionality thesis, this idea that we're simply seeing the universe as it is, we would expect to see a diverse mixture of galaxies. We wouldn't go making assumptions that they're because you have to from a Big Bang universe, you have to calculate their size and age according to their redshift in the model. And there's a lot of circularity in that as well, because you have to assume your cosmology to make that calculation. And if you make the calculation and they're too bright, too luminous, you then turn back the evolution knob. You've got two knobs, and you just adjust that knob to make it fit into the theory. So here you are, you're back into this circular argument. It fits the theory because we've turned the evolution knob down or up. It could be the other way, turned it up in order for it to fit the theory that you already assumed to be true when you made the calculation how luminous they are at their particular redshift distance.
Well, Dr. Hartnett, you are an encyclopedia worth of information. As always, time flies by with you. This was a fascinating show. Another excellent talk. I really appreciate all the work, time, and energy that you put into your presentations, and then also the amount of time that you give us for discussion and Q&A. So, Dr. Hartnett, another excellent program with you, brother. Let's hand it to you in case you had any final words, final thoughts. I've really enjoyed this discussion and Q&A, and I'm glad we got a little bit of cosmology in there as well. Always a fun topic. Dr. Hartnett,
well,
thank you for doing that.
we could talk about another topic in cosmology in the near future, maybe next year.
Sure.
With a friend of mine, Dr. Chris Fulton, who's formerly my PhD student. We are working on a paper that's ready now for submission. We're trying to get into one of the main journals, astrophysical journals. And it's on a quantization of the quasar and galaxy redshifts, but it's not based on looking at the quantized effects in the actual redshifts themselves. It's looking at the spectrum of each object, and we're using the several data sets, Sloan included, 700,000, and the quasar data sets also, and we find a very strict rule of very amazing quantization in terms of the spectra. So these objects, their spectra exhibit this amazing behavior. You have to almost see it to behold how amazing it is. And it applies to quasars and galaxies, and even a region of where maybe quasars and galaxies, this is in redshift space, are mixed, which the argument could be made there. This idea of separating quasars and galaxies into separate categories is wrong. They are all really a continuum, and this is something that anti-Big Bang advocates like Fred Hoyle and Burbidge and Nalika and some of these other people. Alton Arp is a very famous one. I've written many things of what he's discovered, and this supports this argument of the unique creation, I would say creation features that God's created this amazing design, and we can see it in the spectrum of pretty well all astrophysical objects. It's quite spectacular. It would be a challenge to explain it, but I think even some graphs, most people are capable of understanding and seeing the beautiful features of a plot, and to see that these objects have these amazing properties. This is just looking at the bulk collection of them, not the detail, no detail of individuals or anything, to see that they have this amazing properties. And I think we could talk about that next year. Hopefully we can get it published. It seems like we're never ever finishing trying to show the secular world. There's more to the story.
That's right.
Much more to the story.
Well, praise the Lord. I would love to listen and host a presentation on that. Prayers for your efforts, yourself and Dr. Chris. What was last name? Fulton. Okay,
Fulton.
well
Yeah.
that's awesome. That's incredible.
Yeah.
The evidence is out there. I like to say it's a great time to be a biblical creationist. And as time moves forward and we get more and more data and more research, it's just going to increase in terms of the evidence. So, well, right here, Dr. Hartnett, we got Bible Science Forum. I want to encourage, we've been doing this live, so any new viewers that have showed up a little bit later or towards the end of the show in the Q&A, make sure to check the description box for a link to Dr. John Hartnett's website. Many articles, books, and more on several different topics, not just science. You'll find yourself addicted to reading all the material there. And you can also find Dr. Hartnett's past programs here on Stand for Truth. This will be our third, and every single program is always very thorough. So I appreciate that, Dr. Hartnett.
Thank you very much, Donny. Thank you, everybody out there, for listening.
Well, it's my pleasure. Thank you for your time and also the work that you put into your talk. Again, another incredible talk. To the audience, thank you so much for your comments, the feedback. To the critics, hopefully we've planted some seeds. We've addressed your challenges, and we've moved you towards thinking a little more deeply about these topics. Pre-flood versus post-flood lifespan explained, and I do believe that you explained it very well, Dr. Hart. And so with that, Standing for Truth is signing off. God bless.
Okay. Bye.